Okay, so thank you everyone very much for joining. We may have some more joiners coming in, but we'll get started to make sure that we stick to our timings. So I'd like to welcome you all to this fifth installment of the SRI Global Research webinar series. These webinars are delivered every few months to keep the SRI community updated on relevant research. They're hosted by the SRI Global Research Network, which, as I'm sure most of us know, is an international collaborative alliance devoted to the rapid worldwide dissemination of SRI practices, knowledge, and ideas. This network is jointly hosted by the Indonesian SRI Research and Innovation Network and the SRI Rice Center at Cornell University, so you can be sure that we're in good hands. If you'd like to ensure that you're updated about future webinars, then you can sign up to the newsletter on their website, the address of which is below. So to introduce myself, my name is James Dahlgreen. I'm a program director at SRI 2030, which is a small charity based in Oxford, England. We are not a research organization or even an implementer organization. Rather, we work to facilitate the implementation of SRI through government-led efforts, providing strategic advice, technical assistance, and generally our assistance. We focus specifically on Africa, and it is our ambition that SRI becomes the norm here for the benefit of food security, climate change, and citizens. In this webinar, we'll be hearing from Sonali McDermid, who I'll be introducing shortly, who will be delivering a presentation on integrated assessments for mitigation and adaptation co-benefits and trade-offs, a RICE case study. The structure of this will be that Sonali will deliver a 40-minute talk on this topic, which will then be followed by a 20-minute Q&A session. So please, while you are listening, do think of some questions to ask. I'll remind all attendees to please keep themselves muted whilst Sonali or anyone else is speaking to avoid interruptions. And then we can ensure that we proceed smoothly. So finally, I'd like to introduce our speaker for today. Sonali Shukla McDermid is a climate scientist and associate professor in the NYU Department of Environmental Studies. Her research investigates both climate change impacts on agriculture and food security and the impacts of land management on the environment. She is a climate co-lead for the Agricultural Intercomparison Project, evaluating regional climate change impacts on food security. She is also a research affiliate at the NASA Goddard Institute for Space Studies, where she contributes to land and Earth system model development by incorporating and improving land management processes. McDermid is an Andrew Carnegie Fellow and Fulbright Kalam Fellow awardee, which supports her work on climate mitigation and adaptation in agriculture. She holds a BA in physics from NYU and master's and PhD from the Department of Earth and Environmental Sciences at Columbia University. Prior to NYU, she was a NASA postdoctoral fellow at NASA GISS in NYC. So I'm very excited for her speech, as I imagine everyone else is. And it's at this point that I'll hand over to Sonali and her presentation. So over to you, Sonali.
Thank you very much, James. I'm going to share my screen now, and hopefully you all can see that. Can you confirm that, James? Or
yes, I can see your screen.
Okay, great, fabulous. Well, thank you for that nice introduction, James, and thank you, Febri, also for the invitation, and to Lucy for connecting us. I think I see Lucy and Norman and some of the Cornell folks on here. It's nice to see you. So thank you for the opportunity to present this work to the Global SRI Network. It's been a network that my colleagues and I have been aspiring to connect with for quite a while. So this is a good opportunity, and I think we're at a good point to start getting some feedback on work that's taken longer to finish than we had originally hoped, but that's the way of research. So I'll be talking about our findings in testing and trying to understand SRI, in particular in different contexts. But I also want to emphasize that this is a talk not just about results, but about approach. And so I'll be trying to cover both methods and approaches and the philosophy of the approach alongside the results. So with that said, taking a step back and considering the bigger picture here that I think most of us are familiar with, but to start from basics, We are increasingly interested in, we as in researchers, farmers, decision makers across the board, in moving towards agricultural systems and food systems that achieve a range of different outcomes. It used to be about food, fuel, and fiber production. It still is. But increasingly now we have to adapt to changing climate conditions. We need to make agriculture and food production more resilient. We also need to start thinking about reducing greenhouse gas emissions from agriculture. Agriculture has a very big climate footprint, as well as environmental footprint, thinking about water and soils. And we need to do this all while also considering important co-benefits, socioeconomic, livelihood, gender, as well as other environmental variables, biodiversity, for example. So this is all well and good at the global scale. There are solutions emerging. However, at the field scale, it can be difficult to evaluate all of these dimensions in addition to all of the changes under real world conditions. And so I'll make the argument up front that models, evaluated, quality controlled models, can provide some additional insight that augment all of the really great field work and field trials and experimentation that's being done. And so at the regional scale, things get tricky, as we know. What we want to ask the question, what agricultural system transformations actually work biophysically? What can be demonstrated to reduce greenhouse gases, improve water use efficiency, while also increasing yields and maybe productivity? So these are our biophysical co-benefits and trade-offs. And for those strategies that work by the various definitions that we have, and these change depending upon stakeholders, for those that work, how do they intersect with important socioeconomic dimensions like costs, incentive structures, labor, gender dimensions, things that we can't monetize or quantify? Again, these are things that can be really difficult to evaluate in the field. But again, models might be able to provide some insight here so long as we trust them. So these are sort of the big picture questions that motivate the work I'm about to share. And one way that we've attempted to address these things, at least in part, right, addressing all of these things together can be difficult, is through a project called AgMIP, or the Agricultural Model Intercomparison and Improvement Project. And so before getting into the approach, I'll give a quick overview of AgMIP. We're a network of scientists that exists to provide science-based agricultural decision-making models and assessments that are climate change specific. So looking at interactions, so the impacts of climate change, but also feedbacks to climate change in an effort to achieve local to global food security first and foremost, but also to examine those that range of socioeconomic and biophysical co-benefits and trade-offs. We are currently a network of over 1,200 climate scientists around the globe, climate scientists, agronomists, economists, IT experts to help facilitate some of the modeling that we do. We are open, open source, open access. And so we would invite any members on this seminar to join us as well. And right now, and I think this flower diagram is expanding and transforming in different ways, but this is the latest version that I have. We have several dimensions that we work across, and these are coordinated by a team right now that's situated at Columbia. And so we range scales from global economic assessments to more regionalized assessments. These are the regions, countries that we're working in. We look at global gridded crop models as well as point-based crop models. And then we also are in the business of developing data sets, tools, and stakeholder-facing user interfaces to understand the results that we're producing. So it's a very large project, a large volume of work, but again, it's open access, and we're interested in this case of deploying some of what we've learned in AgMIP to SRI and to rice systems. So somewhere within this flower petal diagram is a relatively new project on mitigation and adaptation co-benefits. We're loosely calling this MACB. where we will trial and develop modeling approaches for assessing combined mitigation and adaptation co-benefits and trade-offs across agricultural systems, starting with rice. I should further mention that AgMIP has a firm commitment to stakeholder-driven science and also science that's co-developed with stakeholders. So we're interested in not just pie-in-the-sky modeling solutions, but solutions that stakeholders across a different range of scales and different representation, what stakeholders are actually interested in deploying in the field. And so we work with them to understand what the solution space looks like, and to also quantify and understand and communicate uncertainty to have a shared understanding of that. And what we hope is that in doing this, we can identify appropriate solutions and then help stakeholders to progress towards trialing and scaling these practices more quickly than has been done to date. At least that's the ambition for this work. And so we do this through a common framework that we deploy across a variety of heterogeneous sites and country locations. And so this gets into that approach, right? That philosophy of method. What we're trying to do is develop a standardized evaluation approach and a set of protocols that capture multi-model uncertainty. So for example, going or linking climate models and climate uncertainty with crop models, and moving through to connect that with socioeconomic outcomes using an economic model, which I'll describe in just a second. And through this climate crop economic integration, this forms our integrated assessment, we can start evaluating a bit more completely these mitigation, adaptation, co-benefits, and trade-offs that I've mentioned earlier. Now, what's standard here is the framework and approach, but in doing this at the site-based scale across multiple locations, we're hoping to capture the regional and maybe even site-specific heterogeneity across producers and climate outcomes. So much of this framework that I'm showing here, climate crop economics, and then the outcomes and the testing of solutions, much of this work has historically in AgMIP been focused on adaptation. So we started in earnest on our regional integrated assessments, I want to say about 2010, 2011, so more than 10 years now. And our first large amount of funding was provided by UKAID, DFID, and the intent there was to understand climate change impacts on agriculture and food security, and then work with stakeholders to develop adaptation options. In doing that, we also developed a dashboard that stakeholders could access, which is what you're seeing here, where we provide an overview of our results. In this case, you're looking across South Asia, and this is the Punjab region in Pakistan, where we looked at climate impacts on wheat and cotton. We tested a variety of adaptation options, and through the economic assessment, we were able to consider and quantify the percent of households given a population of farmers that displayed vulnerability to climate change and how the adaptations impacted this population. And so you can see, I'm showing you a screenshot here, but you can toggle across impacts, vulnerability, and adaptation to get a sense of what the modeling approaches can provide. So with what I'm about to present to you here, what we've done is adapted this framework now to not just look at adaptation, but also mitigation concurrently. And what we're hoping to do is augment these results, augment the user interface, and even the stakeholder engagement side of things to consider jointly these adaptation and mitigation outcomes. I should also mention that our first regional integrated assessments spanned about 10 sites, about 5 across Africa and 5 across South Asia. And we're leveraging some of those partnerships for this new work. Okay, so moving onwards to applying the framework that I have just shown now in the context of rice and SRI. So I mentioned that we were multi-model, and this is really important to us. And we are in the early stages of this project still. And I know I feel like I've been saying that for a few years, but multi-model and quantifying uncertainty takes time. but it is important to do. What you're looking at here are broad Asian, East Asian, South Asian, Central Asia projections of climate change for a 1.5 degrees C world, 2 degrees C world, and a 4 degrees C world from the latest UN IPCC, the Intergovernmental Panel on Climate Change. And as you can see, no matter what the warming level, we expect this to manifest regionally in a much more heterogeneous way. Yes, there's warming everywhere. Some places receive more warming than others. Precipitation and extremes in that distribution tends to be even more variable. Coming from the climate side of things, what's important is that we don't take one representative model, but we really try to capture the uncertainty, which in climate has multiple dimensions. The two of which we're concerned about are the uncertainty across models. Different models project different things. What you're looking at is a composite across models, but if I were to show you each individual model of the tens of models that are available, you might see something a little bit different. So there's an axis of model uncertainty. And then there's an axis of storyline uncertainty or mitigation uncertainty. Are we going to track a very heavy fossil fuel driven trajectory, or will we wise up and start mitigating as soon as possible? And so there's uncertainty across the scenario and decision-making space that's worth exploring as well. The second component of that framework, if you move down that flow chart, is crops, right? So we have an assortment of climate models that we then integrate that climate change information into an assortment of crop models. Now, for the adaptation work that I had shown you, that screenshot, we took multiple crop models at every site. That was the first time that had been done, that kind of model intercomparison. And what we found is that, as you can imagine, there are differences between models. In fact, we had 3 or 4 models that actually evaluated really well against field data in terms of yield against the historical or site-based data. And then once we projected future climate change with those crop models, we had sign changes in what the yield outcomes would be. And the question becomes, well, how do you communicate that to a stakeholder? What does that mean? What model is right, quote unquote? For this rice work, the idea of capturing rice yields alongside greenhouse gas emissions, water, soil health, that is relatively new, and rice is a difficult crop to model. So we've struggled as a community in trying to get that, at least in a regionally representative way, to get that accurate and also project future climate change impacts with that. And in order to look at the full benefits of SRI, you can't just be looking at the rice crop itself. You also need to be resolving to some extent those soil processes. So a colleague of ours, Tao Li, who is at Erie at this moment, but has held different positions in different parts of his career, coupled a rice model, so a rice growth model, a RISA, to an actual soil model that resolves key processes related to greenhouse gas fluxes across carbon dioxide, methane, and nitrous oxide, the latter two very important in rice production. We can couple those soil processes with the rice model and therefore resolve at the same time the production impacts, water use efficiency, input factor productivity, alongside the soil processes. There are not that many models that can do this comprehensively. There have been updates to ERISA since we started this work. And so, and we are holding actually a rice model workshop at the end of this month at Erie, specifically to consider and think about this, looking at methane in particular alongside yields. But this kind of work is in its infancy still. So this was a new development that we leveraged for this work. And then lastly, the economic framework that we're using leverages work on a trade-off analysis, a multidimensional trade-off analysis model that was developed out of Oregon State by Roberto Valdivia, who's on this call, on this seminar, and John Antle and a few others. And a key thing about the AgMIT process within the socioeconomic framework is that we have moved away from a representative farming system or the experimental site at which we're learning information about outcomes. Rather, what we're interested in doing is capturing a heterogeneous population of farms, modeling and incorporating data at the site scale for each of the farming households. Now, this includes socioeconomic data for the household, income streams, costs of cultivation. It also includes extensive information about management practices that farmers are using for their agricultural systems, which include multiple crops, it includes animals, it includes other streams of revenue. So we really need to resolve all of that to understand how that whole population is structured, and then what happens when we to that entire population and those outcomes once we introduce changes. That could be the result of climate and environmental changes. It could also, however, be the result of policy changes, access to fertilizers, incentive structures, and so on. But what this model allows us to produce are distributions of outcomes across net farm returns, poverty rates, climate change vulnerability, food security indicators, and ultimately it can give us a sense of adoption rates, who's more likely to adopt. Okay, so with this climate crop modeling framework, we can begin to address some uncertainties that would be useful to understand and bracket a bit more in the context of climate change in rice, and in particular for SRI. So this includes factor productivity, incentives for improved water use efficiency, even labor dimensions. It might help us address questions of adoption and disadoption, which might happen on timescales, beyond which adoption is typically assessed these days, which is 1 or 2 seasons maybe after the initial exposure to SRI training. It also helps us address questions of climate, right? It's true and widely accepted that, for example, reduced water use in rice systems through intermittent flooding or alternate wetting and drying conserve water, but changing climate conditions induce more stress. So how do these practices hold up once you increase the stress levels? It's also very well documented and shown that reduced water mitigates methane emissions, but there are trade-offs with carbon dioxide and nitrous oxide that, again, we can start to resolve with some of these models as well. And ultimately, using that farm population approach, we can start to look at questions of scaling across a population to say, to understand, okay, how much can this practice, this strategy help us to achieve goals laid out in the nationally determined contributions as part of the Paris Agreement or climate adaptation goals. So with that being said, I'll now start to move into some of the results of this work framed by the following simplified research questions. So one, we're interested to use our site-calibrated multi-model approach to understand how rice management interventions, primarily SRI, but also looking at AWD alone, how those compare to conventional management practices. We asked the second question of how do these interventions perform under future climate change conditions? And then lastly, what are the key win-wins that might facilitate adoption? Okay, so I'll right now go into some regional results. So we've deployed this multi-model or this integrated assessment framework, climate, crop, economic, across 3 contexts. We just published a paper in 2024 in Cavi Agriculture and Bioscience on a proof of concept in the Red River Delta in Vietnam, where we leveraged existing data from a project called AgResults, which was a field-based project. And we took that data, incorporated that within our models. Tao had the ERISA DNDC crop soil model calibrated already. And there we did a just climate crop, a future climate crop assessment. And I can show just one result from that in a little bit. Today, however, I will focus on a pilot that goes from climate crop through economics in Bangladesh, where again, we leveraged existing crop field trial data for calibration, but also a very large socioeconomic survey data set. This was supported by ACIR as well. And the Global Research Alliance for Greenhouse Gas Reduction. And I'll touch a little bit on some lessons learned in a full regional integrated assessment where we are undertaking primary data collection rather than leveraging data in Tamil Nadu, India. And that's still an ongoing research project. Okay, so our focus on Bangladesh. We actually worked across 8 districts in Bangladesh. I'm going to focus on 3 here because of these districts were also key districts, and that were the focus of a randomized control trial that was done by Brock, Chris Barrett out of Cornell, which some of you might know, and a few others, to really understand SRI adoption across these particular districts. And so this control trial was set up in a way where farmers were exposed at least twice for varying time periods to SRI training. And then the question was asked about what attributes of the SRI training, how long, how much exposure, how did that lead to adoption outcomes, including spillover effects to farmers who were not trained. Really interesting study, but they had a very rich survey data set that we could leverage for our own information in order to include in our socioeconomic framework and even our crop modeling framework as well too. So their total sample size across these 3 districts was somewhere just around 3,000. We noticed that about 432 sites had complete SRI management information that we could use in our socioeconomic framework and our crop modeling framework. And so at these particular sites, we ran with conventional and AWD as well options in the model, because we can do that fairly easily in model space in order to understand what the differences might be between these management strategies. We also separated the populations within these 3 districts into smaller and larger strata based upon landholding size. And we ran through our integrated assessment with 3 different climate scenarios. One was historical, looking from 1980 to 2010 approximately, so 30 years of historical climate change, and again, focused just on the burrow season, the December through April cropping season. And then we also tested a less extreme climate change based upon temperature, which I'll show you in just a second, and a more extreme climate change. Okay. And so I want to walk you through these results, and I want to make sure that we're understanding where these all come from, because there's lots of uncertainty and dimensionality to bracket here. So the first is on climate change. What you're looking at here is a rather complicated plot that we keep wondering how to improve, so happy to take comments to this end. But what you're looking at here are axes of precipitation change and temperature change as a result of climate model projections for one district. We did this across all of the districts I mentioned. And each point that you're seeing here is a different climate model, those kind of small black dots. We can't run every single model. This is a subset of 25 different climate models. There are 40 plus in AR6, the 6th assessment report for the IPCC. It would be prohibitive. So we want to choose models that allow us to sample that uncertainty space. And so we've plotted this distribution of models. All of them show warming more or less, but some are warmer than others, and some models are wetter than others. Because we're still looking at irrigated systems, temperature we felt was the more important dimension than looking at rainfall for now. And so we selected models that spanned the temperature range. So this is our least extreme climate model. It's sitting at about 1 degree of temperature increase, and our more extreme, which is about 2.5 degree temperature increase. It's not really important at this point what these models are, but this is our less extreme future climate. This is our more extreme future climate. And I'm happy to talk about this in more detail later. This leads us to, again, a very high dimensionality problem. We are now using these models to cross-cut 3 axes of change. That's on management, conventional versus SRI. And we also look at AWD, conventional versus SRI. We can siphon off from that management just the water itself, that looking at AWD or conventional flooding, that allows us to understand, okay, what is the added value and the complexity of the other management principles of SRI, including the soil dynamics, the plant spacing, all of the nutrient management. We can separate that out from the water to understand the role of water versus the other principles. And then we can look across climate and the 3 climate dimensions. And then remember, for the socioeconomic assessment, we're interested in the distribution of those results across farming households. And we can start to compare, okay, what happens now if we change from conventional flooding to AWD, or conventional flooding, conventional management to SRI plus AWD. I'm not going to show you results for all of these, but this is the capacity that we have within the modeling framework. Okay, so what I will show you are results across these 3 districts that compare in the orange. So these colors are consistent throughout these slides, that compare the orange, which is conventional, fully conventional management, conventional flooding, to AWD alone, which is in the blue, so conventional management paired with AWD to some extent, and full SRI, which includes, to the best of our ability, all of the management principles we can represent, which is in the green. This is a baseline figure with absolute results. And so on the top are simulated yields across these management systems under historical climate conditions. And there's about a 5 to 10% difference, not all that significant across the sites. One result that is significant are the methane emissions. And as expected, our model is doing broadly what we think it should be doing. The methane emissions are substantially lower in AWD and SRI, which is not a surprise, but again, a gut check for importance here. It's also important to take these into consideration because a lot of what we show in AgMIP are the relative changes between the 2 systems, or the 3 systems in this case. And so that's what I'll show you now. And I want to walk you through this carefully. So what you're looking at here in the 2 columns compare less extreme climate conditions, so the degree or so temperature increase, with a more extreme temperature increase. And what we're looking across here are average yield changes, percent changes in net farm returns, vulnerability to climate change, and methane. Anything above these dotted lines is positive, meaning we're seeing benefits. Anything below these dotted lines are trade-offs, or not trade-offs, but impacts, more deleterious impacts. And so what we're seeing here, if we start with the columns and just looking at the more extreme climate changes, is that more extreme climate change leads to decreases in yields across the board, although interestingly not as much AWD, but certainly for conventional flooding and to some extent SRI. Although there are some differences between the districts. So I should mention here that these dots are means of the strata, the smaller farms and larger farms across the districts. So there's 6 dots, which are 2 strata for 3 districts. So you're looking at these subpopulation means. So there's a bigger difference across the means here. And in general, climate change depresses net farm returns and results in economic losses, as we would expect. The higher temperatures incur a lot of impact. What's interesting to us is that the less extreme climate changes in some districts and for some strata actually show benefits. It turns out some climate change, at least insofar as it's modeled, and again, it appears to have a benefit. We're not saying it's good, but appears to have a benefit. But it's important to note, and I'll get back to these results in a second, it's important to note that even in these cases, the actual vulnerability of these households to climate change is quite high. The other thing I'll point out is that insofar as farmers are interested and supported in reducing methane emissions, as we would expect, SRI results in lower methane emissions. It does so, however, even more so across the different strata and across the districts than AWD alone. And that comes up a little bit later as well. Now, these are single factors. We're looking at each of these separately. The important thing with this is to look at these together, trade-offs and co-benefits. And so when we do that, slightly different picture emerges.
Sorry, Sonali, could I just ask a quick clarifying question?
On your previous
slide.
Yes.
When you, for example, take the first line, the first row, average relative yield change.
Yeah.
Is that the change from if I take conventional flooding, is that conventional flooding under less extreme climate change versus current conventional flooding?
Yes. So thank you, Adam. I should clarify this. What this is taking the difference of is the less extreme climate change versus the historical climate for this management. So in other words, we're not looking across the management, right? This is just conventional flooding in the past or historically versus conventional flooding under future climate conditions. So we're testing the same management, but different climate. Does that make sense? Okay, great. Thank you for that question. And so what you're looking at here now are key combinations of co-benefits and trade-offs. So on the plots I'm about to show you, the y-axis is always the percent change in net farm returns. So anything above the line is positive. Anything below the line is a net loss. And so we've got win-lose up here, meaning winning for the net farm returns, but losing for methane. The y-axis in this case is methane. Anything that's below the line shows lose-lose, right? You're losing both in terms of net farm returns and in terms of methane mitigation. And so again, we see the biggest differences here are between the crosses, which are least extreme climate change, and the more extreme climate change. In most cases, conventional flooding, and again, you're looking at the strata means here across the 3 districts. And so each one of these is a strata. And we see here conventional flooding tends to lose more in terms of methane. We do have this one district that there are some issues with, so I wouldn't put too much on that, but we do see some losses also with SRI. With water use efficiency, however, because we are including CO2 fertilization effects as well too, we actually see lots of gains in water use efficiency despite this, although there is, again, this distribution of change in net farm returns that span how intense the climate change is. But here's another way to look at this. Again, this is just looking at the management practice alone. This is not switching between management practices. And that's a key element of what we want to look at is adoption. So what this plot asks, same plots, but what they're asking now is what happens if you switch between conventional and AWD or conventional to SRI? And here the narrative changes quite a bit. If you switch, so the red is switching, farmer switching to AWD, the blue is farmer switching to SRI. If you switch, you stand to gain, both in terms of net farm returns, and SRI is significantly higher than, substantially higher than AWD, and in terms of methane mitigation. And even though, so the takeaway here is that even though all these systems experience increases in methane, or most increases in methane under climate change, SRI tends to be better, right? And so you still wind up seeing that SRI co-benefit, and you see that co-benefit quite enhanced compared to AWD alone. This comes out much more strongly in the water use efficiency, where you can see a very clear difference between employing all of the SRI principles with respect to water use efficiency versus just AWD alone, controlling the water alone. And so that brings us to some takeaways for this, and that is that climate change matters, and it might not matter as much in a relative sense, and that SRI does do better as we expect, but it can matter in an absolute sense. So these are things we have to take into consideration. The extent of climate change matters. Less extreme climate changes, and the way to look at this is not climate change is good. It means that if we mitigate heavily now, we can actually help to stave off, right, some of these more extreme changes, and maybe you can maintain some level of farmer socioeconomic status, or potentially have some positive impacts. And most farmers across these sites and across these strata, even the small landholders and even the big landholders, they can experience win-wins through adopting AWD or SRI and actually making that switch. switches to SRI versus AWD are even more consequential and therefore might be incentivized a bit more if farmers perceive that the AWD switch might not incur as big a benefit as they feel is worth it. In practice, I will say these models are not infallible, and we're the first ones to critique our models. They don't capture several key features, and there is a high dimensionality of problems that we're trying to figure out how to navigate around. In the interest of time, this is a quick takeaway from Vietnam on the differences between management and climate. So I will come back to this in the Q&A, but I wanted to just finish off some of these slides.
So now just on
the takeaways.
Left.
5 minutes?
Yeah.
Okay, great, perfect. Okay, so multi-site takeaways. So what I showed you earlier were the results just for Bangladesh. Across Vietnam, Bangladesh, and what's emerging in our India study, though, is fairly robust, right? These SRI management principles can be more resilient to climate change relative to conventional practices. So if we're interested in meeting combined mitigation and adaptation goals, we might think about ways to promote SRI, particularly since beyond mitigation and adaptation alone, they also provide win-win biophysical and socioeconomic outcomes, and they do so even under different climate change scenarios into the future. Of course, to maximize potential, farmers need to tailor SRI principles to their biophysical conditions. This, of course, it relates to all management. It also relates to variety selection, as we've noticed in some of our Vietnam work, again, which I can talk about and show you a supplementary plot in a minute. And finally, of course, all of this needs to be grounded in data, right? We can't just throw our models and act like they'll produce what it is that we want. We do need to undertake very rigorous calibration and validation and evaluation. And to that end, we've been working on ways to understand sensitivity of our models through more hypothetical experimentation. So this is single factor changes where we're just varying over temperature. We've also done multi-factor changes where we vary 2 dimensions between temperature and CO2 to understand how the models respond. But my point with these 2 slides is that these are the first time these models have been applied to the question of SRI. SRI is extremely complex. There are so many different processes going on that our models, they're still in their infancy in being able to handle. So as much field data as we can leverage from people who are actually in the real world conducting field data would be super helpful to us to help develop these capacities a bit more. We also developed, as part of this project, survey instruments, data collection, field crop data collection formats, and systematic experimental field trial testing, so protocols for such testing that enable this model assessment. Those are freely available, and we're happy to distribute those to anybody who's interested in collecting either the crop and or the socioeconomic data needed for this modeling framework, and we are super happy to work with anyone to use these tools and instruments. The last thing I'll quickly say, and I will end here, is that the thing about SRI is that it's so socially fascinating and interesting. There's such a diversity of opinions, mandates, incentives out there. I think with the new emphasis on mitigation in agriculture, it opens opportunities to think about, model, represent different dimensions of SRI in ways that we haven't before, things like carbon markets, new players in this space. In India, Core Carbon X, I think, was providing a small subsidy for farmers to implement a pani pipe within their fields. So there are incentives that are coming online that could facilitate some of these things, but we also need more data collection to understand what the actual benefits and impacts might be. And then there is the question that came up in Bangladesh that we're asking a lot of land, right? Why should farmers mitigate in places that have been the hardest hit by climate change, like Bangladesh? And I think it's a valid question and something that's important. I think with SRI, what we can lean on is that it's not just about mitigation, it's about a whole new way to think about rice farming systems and to really work with the complexity that's there. And so it's not just for mitigation's sake that we would kind of look at this, and that's evidenced by the water use efficiency savings and several other things, I'm sure, that we're not capturing just yet. But it is a fair question and one that we've confronted. So with that, I will end. I know that was a lot of information. I probably spoke way too quickly, but I have lots of supplementary plots. And of course, I'm happy to have ongoing conversations a lot of people were involved in this. My very close and great colleague, Roberto Valdivia, our economist, is on this call and can answer all the difficult questions. And I will say thank you and leave you with that.
Thank you so much, Sonali, for that very interesting talk. I mean, it was an absolute delight to listen to. The SRI research community, I'd say, is quite focused on agronomic research. So it's a pleasure to hear research that's not only climate focused, but is comprehensive really across agronomy, climate, and those social contexts. And the takeaways, it's useful to be reminded that things are getting worse. This isn't things are going to get worse. Temperatures are going to increase, and the climate is going to become increasingly unpredictable. And it's useful to see that these conventional practices really are high risk for those future warming scenarios. And it's good to see that SRI is effective in protecting against that future change. I think, to me, importantly, the inclusion of social modeling is something that was very helpful in your research in terms of selecting something that is feasible to scale rather than just something which is perfect on paper but not implementable in real life. So I'm really looking forward to keeping up with this and seeing where it goes. So now we'll be moving on to the second section of the webinar. So we've got 20 minutes for a Q&A session, so the more involved section. Audience members, please feel free to ask questions either via the chat feature or by raising your hand, and I will come to you. So feel free, we'll start this section now. And I can see that Norman, you're the first one with your hand raised, so we'll start with you.
Okay, thank you very much, Sonali. I'm glad to see that you've made so much progress since we last had a chance to talk about this. I look forward to your visiting Ithaca sometime where we can go into more detail. In terms of a question, there are lots of questions. I was interested that your colleagues at Oregon State are doing the economic dimensions of this. And I was wondering how they're dealing with the fact that when you're analyzing SRI, it's one of the unusual situations where you have possibilities of win-win or positive sum outcomes rather than trade-offs. Economics as a discipline has really built its strengths on doing sort of closed system, zero-sum analysis. And when SRI, by making better use of water and by mobilizing the services of microorganisms and other soil organisms, when it's doing things differently from conventional agriculture, you create a different framework in which to look at economic costs and benefits. And I'm wondering if the colleagues we have in your network who do economics have really thought very much about or gotten very deeply involved in thinking about how you model, how you incorporate win-win positive sum situations when the corpus of economic analysis really posits trade-offs for virtually everything. That's a very different analytical posture to work with.
Yeah, thank you very much for that question.
Sorry.
And I'll hand it to Sonali.
Thanks, James. So Norman, are you, just to make sure I understand the question, are you asking if it's possible to consider co-benefits that might result, and I see Roberto came online here, which is good because he's the economist and can answer this a bit more, but are you asking, is it possible to consider co-benefits beyond just the net farm returns as pegged to the yields, like to look at dimensions of soil health and other agricultural, agroecosystem indicators beyond just sort of the conventional, what we do conventionally, which is sort of yields and net farm returns pegged to yields? Is that what you're asking?
I'm asking a conceptual question. Maybe it's one we can't answer very clearly, but it's one I will continue to worry about. That if our way of thinking about economics is always trade-offs, you vote, for gain, there's a loss, and for many situations that that's true. But in SRI, what's attracted me to it was that you have win-win situations where you can, and it's one thing to say we look at win-win, but how do you incorporate them into your frame of reference, your framework for thinking? Maybe that's just a question I can put on the table for everyone, because I don't have a good answer, and maybe you don't have either.
Yeah, well, and I am curious if there's time to hear what Roberto has to think. I mean, I'll just say, taking a step back, you know, I've struggled with this personally because I'm not an economist, I'm a climate scientist, but I think what's really interesting about this project and AgMIP and what we've done in AgMIP as a whole is we're being forced to talk to each other across disciplines, and we have different definitions of things and what we want. I think that's been healthy. The way I see it is that, you know, we're using these terms, so and it's not just semantic, words matter, but trade-offs and co-benefits. But I do think what we're seeing in this MACB project writ large and SRI more specifically is, and thinking about mitigation and adaptation, is sort of forcing us to think along other dimensions of the problem that we're right now calling trade-offs and co-benefits, but at a later date, in other words, it's allowing us, Norman, to capture some of the complexity and outcomes across different outcomes that I don't know that we've actually emphasized before. We haven't really emphasized water, you know, in the work that we've done, completely water savings in the way that we have. We haven't really emphasized soil health much at all. We haven't really looked at the whole population of you know, greenhouse gas species. So, and that's not even related to the things you're talking about, but I do think that we have an opportunity here to look at a little bit, tiny bit more comprehensively, full agroecosystem dynamics, that we're trying to slot this new way of looking at things into this existing economic framework. And I think the framework is really powerful, but the words that we use to describe that and how we talk about that and how that leads to different incentive structures, there's an opportunity here to workshop that with this group. Roberto, I don't know if you have any other quick things to say, but maybe your input would be useful here.
Well, I'll just say that I think it's really exciting what you're doing, and you're aware that there are these conceptual or methodological constraints you have to wrestle with, and so I wish you Godspeed.
Thank you.
Roberto,
Yeah, Roberto.
Just for 30 seconds, and then we'll move on to the next question.
Yes, quickly, and thank you, Norman. This is a interesting question and not easy to answer. But what I would say is, this model that we have developed with my colleague John Antor many years ago, let's put it this way: we are a little bit against just a pure benefit cost analysis. And one of the features of our modeling approach is to characterize the heterogeneity in a region. When I say heterogeneity, is socioeconomic, biophysical, environmental heterogeneity. Farmers manage their farms differently. There are different soils, different conditions, and that allows us to look at these results, distributional results in the region. And we can differentiate, for example, in the results that Sonali presented, those are, for example, the means changes in yields and farm income or methane emissions in a population of farms. But we can even disaggregate those between those who adopt, what are the outcomes for those who adopt, what are the benefits for those who adopt, and those who don't adopt, right? So we can even stratify that level of analysis. So I would just keep there, but I take your point, and that's one of the goals of our model. That's what we call it, multidimensional impact assessment, trying to cover not just production, yields, and income, but how that correlates with other kind of outcomes. And any outcome, if we have data, of course, like gender, nutrition, soil conditions, soil, you know, quality, and so on. So,
Thank you.
Thank you, Roberto, Norman, and Sonali, for that. Actually, the next question I was just going to select from the audience. I see that Sonali, you've just answered it, but it might be useful to hear an expansion on that. And it's from Maya,
for sure.
Who says that with this SRI modeling, is it under the assumption that SRI is perfect, i.e. all steps implemented? I think this is something that is very relevant, you know, to with regards to us understanding that SRI is something that can be implemented in parts and is not necessarily a completely perfect practice when implemented on the ground. Thank you, Sonali.
Yeah, absolutely. Thank you, James. And thank you, Maya. Hi, Maya. Yeah, so great question. And the answer is, I am not an evangelist for models, I promise. But the beauty of model world is that we can do all of the above. So what we try to do, and being serious now, is like in India, for example, but also leveraging the data set from Brock, we try to implement whatever farmers say that they're doing, right? So you can imagine a first step where you're kind of modeling conventional, and then if farmers have adopted SRI in however they feel SRI is implemented, and they tell us what that management is. So we're administering, our survey instrument includes a whole host of dimensions to ascertain the actual management principles across water, nutrients, crop variety, et cetera. So we actually can implement within the crop modeling framework, and then also within the socioeconomic modeling framework, how much you're paying for fertilizer and the amount that you apply and so on and so forth. We can implement that sort of real world farmer strategy as reported to us in the modeling framework. And so some farmers, and we did, I think this was the case, Roberto, on the Brock data set, some farmers implement, a couple of principles. Some farmers try to implement everything. We can capture that heterogeneity and diversity within model space. Of course, it makes it tricky because that's another dimension that's unique to SRI in that way, is that in addition to the climate dimension of uncertainty and then the crop model structural dimension of uncertainty, so what those models are actually, how they're formulated, the management uncertainty for SRI just explodes because you have so many principles. So you start multiplying that matrix and it's massive. But we deployed experimental field trials through TNAU. This was devised by some folks at TNAU. I'm sure many people practicing SRI in the field do things like that, where we've partitioned the different management principles and then put them all together, and then we can implement that within the framework, the model framework. So no, the management does not have to be perfect. We can capture that heterogeneity. And then the cool thing is we can say, okay, so all farmers are doing this practice. Some of them do this practice, others do this. Let's take that heterogeneity and model it. Then we can run a new hypothetical idealized experiment where we say, what if all farmers do everything? And we haven't done that yet, or sort of within the Bangladesh work. We've done that with AWD and SRI. But what could be really interesting about that is that if we find, for example, that adding all the principles actually leads to declines in some farms, it suggests that they've optimized SRI for their conditions, right? And we can actually demonstrate that, assuming we've calibrated the models well, within model space. And that's not a question specifically that we've addressed just yet. But we have the possibility and capacity to do so. I don't know what that would gain us other than proving the farmer right, which is probably what we want to do because they know what they're doing in most cases. But those who've adopted SRI already, but I guess for those who haven't adopted SRI, you could potentially play with some of those principles in a way that considers optimization for the site and location. Does that answer your question?
I think
Thanks, Sonali.
Yeah, great.
Yeah, I think that was a really good answer. I mean, what I hear again and again from you is that you're trying as much as possible to reflect real world conditions, which is, of course, of utmost importance. And I was excited to hear that this model could be used to find the perfect implementational version of SRI location. That's a big ambition. So I'm hopeful that
maybe close to perfect. I don't know. Yeah, close to perfect. Yeah.
So I'd like to hand over to Adam, who has the next question for you, Sonali. And we've got 5 minutes left for questions after this. Adam.
Okay, I'll be brief. So my question has two parts. I looked at the tremendous dashboard that you guys have created with specific areas. And I was looking at Karnal in northern India. And on the adaptation tab, it says that the model suggests that a majority of farms could adopt the proposed adaptation package of increase in irrigation, decrease in crop season length for rice, and increase in fertilizer application rates that potentially could offset the impact of climate change. first of all, I wonder if that is simply what various studies have suggested, because it looks to me like the precise opposite of what we should be doing to adapt to climate change, putting more fertilizer and more irrigation. That's kind of why we're in the problems we've got to start with, right? But I guess the more important question for me, if I could ask you this, is if you look at that as an example, how is your work going to influence government policy and practice at scale? What's your thinking about the kind of how you're going to translate these insights into action?
Yeah, so a couple things about that, and less than 5 minutes. So a lot of that work, so it's interesting. It could be interesting to revisit that work. I mean, that work has taken place over the course of a decade, and a lot of the adaptations that we tested were things that were I'll call it loosely stakeholder driven, but we were sort of in this process of so I won't say personally that I'm a proponent of every single adaptation option we tested. I think from my perspective, and Roberto might disagree, from my perspective, this is the first time that we had developed intercompared these models, and the first time that we were really using them to look at climate change adaptation. And so what we were testing was a response to stakeholders on the ground, whatever their incentive structures were, and things that we could implement relatively easily, harmonized across so many models that take inputs differently, in order to assess, do we have consensus on those results? So it would be interesting to revisit those sites now, and in fact, we are in discussion to do that with SRI instead, and say, okay, how much more do we gain, or what are the benefits into the environment as a result of SRI versus these more fossil fuel, like these kind of conventionally driven scenarios. I'll also quickly say on that, Adam, what we did when we thought about adaptations, what we did is we also paired adaptations with different trajectories of agricultural decision making. So at the national scale, so we called these representative agricultural pathways. Roberto can speak more to that. But what we did is we modeled a set of assumptions about how does agriculture develop under a more conventional fossil fuel driven situation, and how would it develop more sustainably? And you can parcel out adaptation options along those two dimensions. So we're asking more questions than we are at this point establishing answers. To your point on policymakers now, the slide that I cut out all my SRI slides because I figured this community knew them already. But when we talk about this to people who are not familiar with SRI, what we say is that we are interested in SRI because it's actually featuring now increasingly, or at least some principles within countries' nationally determined contributions or their national adaptation plans. And so in the Bangladesh case, so in the India case, that was stakeholder driven in the sense that the local water board along the Kaveri River was interested in water security. And so they were interested in how AWG specifically would aid autonomy within that particular area of rice growers. In Bangladesh and in Vietnam, it was driven by national policy because they were interested in looking at water management in particular, but some SRI principles more broadly, in order to meet the mitigation goals. So in very few circumstances in AgMIP are we testing things that haven't been suggested at different levels of policymaking. And you can even have disputes across different levels of decision makers, right, within the government space. And we kind of resolve that by testing all of the above. So we're not making things up as much as we're responding to those conditions. And then what we've done in that last slide that I had shown with all the faces, we have regular stakeholder workshops that bring in ministry level officials to actually not just show the results, but then discuss and co-develop what the next set of testing should be. And we've done this in two ways. One is, here are what the models show, here's what the models can do, what would you like us to test? The second is in the national agricultural pathways that I just mentioned, where we try to model practices consistent with agricultural development. Roberto has actually led these. We've had workshops where we've sat with decision makers and policymakers to say, okay, what do you think under a fossil fuel driven trajectory would happen to fertilizer prices? What do you think would happen to charging for electricity to run your pumps? That sort of thing. And we get them to co-develop these agricultural pathways with us that we then test into the modeling framework. So it's not just like we're handing information off to decision makers. We actually have protocols for involving them in the discussion at the table. The problem or it's not a problem, but one of the challenges that arises from that is that different policymakers have different ambitions, intentions, and incentives, and they don't. We've had very interesting discussions, let's put it that way, or lively, about what we should be testing between the decision makers, not across the modelers. So that's been an interesting socio-political situation to observe. But I wouldn't want to come across as an a priori proponent of anything. What we try to do is look at those results. And in the previous Northern India results, Adam, we weren't looking at the environmental co-benefits as much. I don't know if that answers your question, but yeah.
Sonali,
Right.
thank you very much for that answer and explanation there. And that really brings us to the end of the Q&A session. There was a few more questions that were asked that we don't have time to answer, but I'm sure we can contact you via an email address or get in contact with you personally. And just on the last point, it's good to hear that there is a system for implementing these suggestions and changes to ensure that this research doesn't stay within academia and it delivers to those people that need it and those governments that are requesting this help.
Wonderful. Thank you so much, James.
Yeah, thank you very much. That takes us to the end of this session and this discussion. Before we leave, I know that our friends who are organizing this would like to take a picture of everyone here. So if everybody could please switch their cameras on if you're comfortable, and then we'll take a picture together just before leaving. February or Thomas, I don't know if you'd like to lead this.
Yes, I will take the screenshot, James. All right, so everyone, you guys can turn on the camera. We want to take a screenshot. Right, so I'll take the screenshot for the first slide in 1, 2, and 3. So I will take the screenshot for the second slide in 1, 2, and 3. All right, thank you, everyone.
Thank you, Thomas. Thank you, everyone, for attending. It's a delight to see you all here. It's a delight to have this community be so active. I'm looking forward to the next one in the webinar series, and I'm sure you are too. Thank you so much for coming. Thanks for February and Thomas and everyone behind the scenes for organizing this, and have a good rest of your day. Goodbye. And Sonali, thank you to Sonali. Sorry, the star of the show.
No, of course. Of course. No, thank you to everyone else. Bye, everybody.
Goodbye. Thank you.
Thank you, Sonali. Thank you all. Bye.
Thank you.
Bye.
Bye. Very much. Yeah.